Now we will learn about network architecture and cables. There are three types of cables. 1. Crossover cables. 2. Straight-through cable. 3. Rollover cable. First, crossover cable. Previously for switch-to-switch connectivity we used crossover cable, but now we use straight-through cable. When automatic medium-dependent interface crossover auto is enabled on an interface, the interface automatically detects the required cable connection type, straight-through or crossover, and configures the connection appropriately. This helps to overcome the limitation. Straight-through cable. Straight cable is used to connect host to switch, host to hub, switch to router, etc. Both ends of the pin are connected through. As of now, most of the networks are connected through this cable, rollover cable. A rollover cable, also known as a console cable or a management cable. One end of this cable is connected to a PC or laptop, and the end is connected to a networking device. Best example of this cable is console cable, RS-232. Ethernet cables with two main types. 1. Twisted pair and 2. Fiber optics. Copper cables categories are Cat5, Cat6, and Cat7. These have different types of transfer rate and maximum length and other specifications. Fiber optic Ethernet cables use glass or plastic fibers to transmit data, offering higher speeds and longer distances but are more expensive. Types of optic fiber cables. Single-mode fiber, SMF. Single-mode fiber is used for long-distance transmissions and can carry data over tens of kilometers without any signal degradation. It has a small core diameter of 9 micrometers, which allows a single mode of light to pass through it. Single-mode fiber is used in applications such as telecommunications, data centers, and long-distance networking. Multi-mode fiber, MMF. Multi-mode fiber has a larger core diameter of 50 micrometers or 62.5 micrometers and can transmit multiple modes of light at the same time. MMF is commonly used for shorter distance transmissions, such as within buildings or campus networks. It is less expensive than SMF but has lower bandwidth and is more susceptible to signal attenuation. Optical fiber, POF. POF is made of plastic material and has a core diameter of 1 millimeter or larger. It is used for short-distance transmissions, such as in home networking, automotive applications, and industrial automation. POF is less expensive than glass fiber and is easier to install, but it has lower bandwidth and is more susceptible to signal loss. Ribbon fiber. Ribbon fiber is a type of optical fiber cable that contains multiple fibers arranged in a flat ribbon shape. Ribbon fiber is used in high-density applications, such as data centers and telecommunications where space is limited and a large number of fibers need to be routed through a small area. Loose tube fiber. Loose tube fiber cables have a gel-filled central tube that protects the fibers from environmental factors, such as temperature changes and moisture. Loose tube fiber is used in outdoor applications, such as telecommunications, where the cables need to withstand harsh weather conditions. Tight buffered fiber. Tight buffered fiber cables have a protective coating applied directly to the fiber, which makes them more rugged and durable. Tight buffered fiber is used in indoor applications, such as patch cords and equipment connections. Most commonly used are single-mode and multi-mode fibers. Multi-mode fibers are identified by the OHM optical mode designation, and their specifications are outlined by the ISO IEC 11801 standard. Types of OHM cables are OM1, OM2, OM3, OM4, and OM5. We will learn small office connectivity. In the small office, all the device is connected to a switch, and the switch is connected to the router. This router is connected to the ISP. In some cases, you can see two switches. One is connected to end devices and users. Second switch is connected to servers and the router. The router is connected to firewall. This firewall will be connected to ISP. In home network, all the Wi-Fi and wired devices connected to Wi-Fi enable router. This router is configured with ISP setting to connect the internet. Now we will learn about network architecture. There are three types of layers in network architecture: access layer, distribution layer, core layer. Access layer. Access layer is the lower layer in network architecture, where all the end users and devices are connected in this layer. These switches are also called access switches. Loop prevention mechanisms like STP, RSTP, PVST, MST are used in this layer. Layer 2 security is configured in this layer. This layer's drawback is it's a single point of failure. To overcome this drawback, Layer 2 will be configured. Layer 2 is also called the distribution layer. Distribution layer. This layer connected to both core and access layer. Multi-layer switches are used in this layer. Single point of failure is eliminated in this layer. Multiple multi-layer switches are used as redundant in this layer. Distribution policies are also used in this layer. Core layer. This is also known as backbone network. This network is connected to the distribution layer.